Hello class. Today we're going to cover 5.1. I apologize for all the technical issues. The Apple iOS was having issues, and so I finally figured this out and got it working. So we're back up and running. So today we're going to talk about polar coordinates. And the first thing that I need to talk about is just some basics that you need to know. We need to have a point, and so that point is typically called the pole. And then we draw a ray, and that ray is the polar axis. And then to develop an angle, we just need to simply create an angle. And the angle that's created is this one is called theta. And it comes about this way. So it's the pole is that center point where the vertex is. The polar axis is always along the x-axis in the positive direction. And then the angle is counterclockwise red. That's positive. If you go clockwise, your angle will be negative. When we talk about polar coordinates, a point that's given on it is given in terms of radius and then angle. So whenever you see a polar coordinate, the first thing you're going to see is the radius and then the angle. So let's go ahead and do an example of that. So this first example, we know that the radius is 3 and that our angle is 5 pi over 6. So let me go ahead and draw that for you. So here is my pole. Here is my polar axis, and we know that the polar axis, that the radius is going to be 3, so that distance is going to be 3, and then we'll come over and draw what 5 pi over 6 is, so we can see that this angle here should be 5 pi over 6. And this point over here, this point is going to be 5 pi over 6. And that's how you actually plot this point. So we use our polar axis. We're going to rotate 5 pi over 6. And then this distance from here to here we know is 3 because that's the radius. And we plot our point, and there it is. All right, for B, again, we're going to have our pole. I want to write that thing so it's. There's our polar axis, and now we have a negative pi over 4. So that's going to be something like this. With a radius again of 2. So here's our point. This angle here is a negative pi over 4. And so this point right here is 2, comma, negative pi over 4. Another way we could write that point too is if we wanted to reference it the other way, the angle could go this way, and then that angle would be 7 pi over 4. And so that same point, if we rotated the other way, would have been 7 pi over 4. So that's just another way to illustrate that same point. It's going to be important for us to understand coming from it from both ways. And so it's important that you guys are able to understand and get that. All right, let's do another example. So here we're given a little bit more information. And so again, 3 is the radius and pi over 6 is our degrees. But one thing I want you to notice in this problem is in A, we're restricted to full rotation. So we're going 2 pi to 4 pi. And so when I graph this A1, I'm going to get, here's my pole. There's my polar axis. And then we see it's pi over 6, right? So that's going to be something like this. Let me make this thing so it works nicely. There's my pole. If this is the angle, that would be pi over 6, right? But the angle that we're doing, since we're between 2 pi and pi, I have to go full circle plus go over. And so what that ends up doing is it creates an angle that's 13 pi over 6. And so our radius in this problem is 3. So this point here would be 13 pi over 6, and that's our point. Now, you might ask, how did I get 13 pi over 6? And here's how I did it. We know that pi over 6 is going to be just this piece here, right? But we did a full rotation, which is 2 pi. So when we get common denominators, that will be 12 pi over 6. And so adding those up, I'm going to get 13 pi over 6. And that's my angle that I'm going to get. Okay, in the next example, notice here that the radius is now negative. So that's the piece that's going to be important. In this case, we look at, we're only doing one rotation. We're within one rotation, but the radius is now negative. And so the way we graph this guy is we're going to get, again, it's going to be that pi over 6, right? But since it's a negative radius, instead of going pi over 6, we're going to go the other way. And so we see that that is our radius. It's a little bit tricky, right? So the radius is 3, but now the radius here is negative 3 because it's going the other direction. And so our point here is going to be negative 3. And then if this was pi over 6, how much did we add to it? Didn't we add basically a half circle rotation? So that's going to be pi over 6 plus pi, which then that's going to be pi over 6 plus 6 pi over 6, which will give us 7 pi over 6. And so this is going to be 7 pi over 6. That's where we're at. A little bit tricky, but the key there is this radius here was positive. When we go negative, we're just going to go the opposite direction of what positive is. And that's how we plot that point. Okay, here's a theorem that we're going to be using. The critical piece to it is x is equal to r cosine theta and y is equal to sine theta, r sine theta. We're going to be using that in order to be able to convert. And so here's a quick example that's going to use that information. And so here it is. For A here, I'm going to get x is equal to r cosine theta, right? And so I know that my r in A is 6. So I'm going to get 6 cosine, and then my angle is pi over 6. And so x is going to be equal to 6, and that's going to be radical 3 over 2 because we have our unit circle notes, and that'll be 3 rad 3. For our y, we're going to go r sine theta, and we're going to use that same information. Again, the radius is 6. The degree, or the radians, is pi over 6. That's going to be 6 times 1/2, or y is equal to 3. And so our rectangular coordinates for this are going to be 3 radical 3 comma 3. That's the answer for part A. For B, again, I like to write the formulas that I'm using. So I'm going to go x is equal to a negative 4 cosine of negative pi over 4. which is going to give me negative 4, and that's going to be radical 2 over 2. So x is going to be a negative 2 radical 2. Now for my y, it's going to be r sine theta, and so I'm going to get negative 4 sine of negative pi over 4. But that's going to become 4 sine of pi over 4, and the reason that is because sine is odd, so the negative can come right out. And I know that's going to be 4 times radical 2 over 2, which will give me y is 2 radical 2. And so my coordinates are going to be negative 2 radical 2, comma 2 radical 2. And that is the rectangular coordinates for part B. I'll leave that there for a second just for you to be able to look at and seeing this process. Okay, the next example, we're going to get a little bit trickier. So we're going to convert rectangular coordinates to polar, or go polar to rectangular. We're going to do both ways. So in this example, we're going to go find the polar coordinates based off the rectangular coordinates. So one of the things that we need to know is that r is equal to, or r squared is equal to x squared plus y squared, right? That's the equation of a circle. And we could think of it as the square root of x squared plus y squared. And we also need to know that tangent of theta is equal to y over x. This is something we saw in chapter 4 that you should be able to recall. So to find the radius, we know what our x is. Our x is 2, so when we square that, and then negative 2 for y, and square that, we're going to get r is equal to 4 plus 4, or r is equal to the square root of 8, and that can clean up to be 2 radical 2. Now using the degrees, the tangent formula, we're going to go tangent theta is equal to negative 2 over 2, or tangent theta is equal to negative 1. So to get our theta, we're going to go tan inverse of negative 1, and that is at negative pi over 4. And the reason that is because if we recall, tan inverse has to be in the first or fourth quadrant, and so we're restricted from pi over 2 to negative pi over 2, or if you want to say it the right way, it's from negative pi over 2 to pi over 2. And so if I draw a picture, we're restricted to here and here, but it's not necessarily that's the only answer. So we end up falling over here, right? And this is a negative pi over 4 shift. But where is tangent theta negative 1? It's in quadrant 3 also. So it's also going to be at let's see, pi over 4, 2 pi over 4, 3 pi over 4. This is 3 pi over 4. And so that's another possibility. And so the solutions to this thing is going to be obviously the one that we calculated, 2 radical 2 negative pi over 4. That's the easiest one. But it could also be 2 radical 2 of 7 pi over 4. And the way they're getting the 7 pi over 4, I want to show that to you, is if I go this way to it, isn't that a 7 pi over 4 rotation? Or it could be 2 radical 2 and then 3 pi over 4, because we're in that third quadrant. So these are all 3 possibilities, because this guy is tangent of 3 pi over 4 is -1, along with this being also tan of that angle being -1. Okay, let's do another example. And so in this example here, we're going to find again the polar coordinates. So using the formula again, and they're written down below, I'm going to get r is equal to the square root of -1 squared plus a negative radical 3 squared, which will give me the square root of 1 plus 3, or r is equal to 2. So we know that the radius for this problem is 2. And then tan of theta is going to be equal to, again, y over x. So then tan of theta is going to be equal to radical 3 over 1. Both being negative, the negatives are going to drop. And so tan theta is equal to radical 3. Theta is equal to tan inverse of radical 3. And so where does that happen? If we were to draw coordinates, we know that at pi over 3, we get radical 3 for tangent. And so we can get that. But since we're negative, right, we know that negative is going to be in quadrant 3. So what's actually happening is we're somewhere down here. And so our theta should be at 4 pi over 3. And so to do this, the result is going to be 2 4 pi over 3. Or it can be -2 pi over 3, right? Because we showed that if this is the positive side, going a negative radius takes us back this way. And so that's how they get that -2 with pi over 3, because the radius is going the other way. Or you could have written it as 2 comma a -2 pi over 3. And so that's taking the angle going this way to it, instead of going the other way to 4 pi over 3. So we've got to think about multiple ways on how to do this problem. You can see that the graphing of this can be a little bit tricky. This is going to take some practice, but I believe you guys can do it. All right, let's do another example. Now here we're going to take an equation in polar and turn it into rectangular. And so we have our polar coordinate of r is equal to 6 cosine theta. We can do some algebraic tricks to it. So if I multiply both sides by r, I'm going to get r squared is equal to 6r cosine theta. But what's cool is, isn't this part that I just highlighted, isn't that x? And so I can say r squared is equal to 6x. And again, I can write this down so just so you guys know. X is equal to r cosine theta, and y is equal to r sine theta. So those are the two tricks that you're going to use. Now, one of the things that we know too is that r squared is equal to x squared plus y squared. But we can substitute r squared as 6x. And so we end up with 6x is equal to x squared plus y squared. And then doing some algebra, we can do this, and then completing the square, we take half of 6 is 3, and then square that 3, we end up with 9. And so since we added 9 to one side, we have to add 9 to the other side. And then we need to recall that this factors, and we come up with an equation of a circle. Well, That's great. The center of the circle is going to be 3, 0. And we know that the radius is 3. This is something that we've done earlier, but this is the trick to do it. So let me do another example for you real fast. So in this example, we have 4xy is equal to 9. And what I'm going to do is I'm going to use the fact that x is equal to r cosine theta and that y is equal to r sine theta. So I'm going to go 4 times r cosine theta times r sine theta is equal to 9. Now if I multiply this, I'm going to get 4r squared cosine theta sine theta is equal to 9. But I know I can break this up with some trig tricks. And so what this ends up giving me is 2r squared sine 2 theta is equal to 9. This is the equation that we can use in polar, or this one would have been good enough too without converting. I really would be fine with this one. I think it's less work and it's still effective, and you guys can get all the information that you need from it. This is 5.1. I hope you find this to be useful. I will be doing 5.2 for you tomorrow and posting it. But just be prepared. That's going to be quite a lesson. There's quite a bit there for you. As always, all the best.